In this lesson, we want to talk about conic sections, and here specifically we want to focus on the hyperbola. All right, so now that we just got finished talking about graphing an ellipse and the properties of an ellipse, we move on to the hyperbola. So the hyperbola is going to be very similar in terms of its equation, but very different in terms of its shape and how we go about graphing it. So the hyperbola is the set of all points in a plane such that the absolute value of the difference of the distances from two fixed points is constant. Again, these two fixed points are called the foci of the hyperbola. Now, when we start looking at the equation of a hyperbola, again, it's going to look very similar to the equation for an ellipse. So this guy is centered at the origin, and we're going to find out why in a minute, but it's going to open to the right and to the left. So we're going to have one what we call branch opening to the right, and one branch that opens to the left. So just to show you a little preview of this, we're going to graph this in a minute, but one branch opens to the right and the other opens to the left. So let's talk a little bit about why that happens. And to do that, I want to just stop and talk about an ellipse for a moment. So we know if we saw something like x squared over 9 plus y squared over 16 equals 1, this is an ellipse, okay? So the plus here gives me an ellipse. The minus here is what gives me a hyperbola, okay? So why are these two going to be such a different shape? We saw the shape of the hyperbola. If we look at the ellipse, it's an oval shape. So what's creating the disparity between the two shapes? Well, it's that minus sign. X squared over 9 plus y squared over 16 equals 1. Forget about the formulas and all that stuff. I just want you to think back to x and y intercepts. Okay, this is how this is going to make sense. How do we get this point, this point, this point, and this point? Let's think about this. If I plug in a 0 for y, I'm getting my x-intercepts. Plug in a 0 for y, this is gone. So you have x squared over 9 is equal to 1. Okay, multiply both sides by 9. I've got x squared is equal to 9, which gives me a solution of x is equal to 3, and then also x is equal to negative 3. So you could say x equals plus or minus 3 if you want. Okay, so that's where this came from because, again, y is 0. So we would say 3, 0 there. That's where this came from. Again, y is 0, so negative 3, 0. Okay, so that's where those 2 points came from. Now, additionally, we're going to have points here and here. So where do those come from? Again, think about plugging in a 0 for x to get your y-intercepts. So here you'd have y squared over 16 equals 1. And again, y squared equals 16. If I multiply both sides by 16, and y is going to equal plus or minus 4. Okay, so that's how I get 0, 4 and 0, negative 4. And we already know about the equation of an ellipse, so on and so forth. I just want to show you that you end up with these kind of intercepts in this case. So you're able to sketch this graph through these 4 points. So that's what's creating this shape. Now, when we go back to the hyperbola, you're not going to get these 4 points to connect. Okay, and the reason is because of this minus sign. Let's think about this for a second. If I have x squared over 9 minus y squared over 16 equals 1, plug in a 0 for y, it's a similar thought process. X squared over 9 equals 1. X is going to equal plus or minus 3. Okay, so that means that 3, 0 is on the graph, and negative 3, 0 is on the graph. We can see those points right here, right? Here's 3, 0, here's negative 3, 0. Okay, so from the center, I'm going 3 units to the right, I'm going 3 units to the left. We're going to find out in a minute that that distance, again, is called a. Okay, in this particular case, we know that when we work with these equations, we have these generic forms. So right now, I'm just going to write that a is equal to 3. Okay, we'll revisit that in a moment. How do we get the y-intercepts here? I'm just going to erase that. Well, I could plug in a 0 for x. This would go away. You'd have negative y squared over 16 is equal to 1. Multiply both sides by negative 16 to clear the denominator and the negative. You're going to have y squared is equal to negative 16, okay, which doesn't have a real solution, right? If I took the square root of this side, I'd have y. If I go plus or minus the square root of this side, okay, you're going to have a complex solution there, or a non-real complex solution to be specific, right? One with the imaginary unit I. We won't have this on our coordinate plane, so we won't have any y-intercepts. So that's why, if you look at the graph, you don't see any points where this guy is going to intersect the y-axis. That's what's creating that, and that's why we have a shape that is opening to the right and opening to the left, right? You don't have anything on the y-axis like you had with your ellipse, right? You have points up here that you can connect, so that's why there's a drastically different shape between this guy and this guy, okay? So let's talk a little bit more about our hyperbola in general. So I'm just going to go up here to kind of the equations you'd see in your book and run through them real quick. So this is the one we're working with where we have the minus in front of the y squared over b squared. The other one is where you have the minus in front of the x squared over b squared. Whatever has the minus in front of it, again, because of that minus sign, in this case, you wouldn't have x-intercepts, so this guy's going to open up and down, okay? And we'll see an example of that later on. In this case, we already know we won't have y-intercepts, so it's going to open to the right and to the left, okay? So that's what's causing that. Now, your vertices, okay, your vertices are going to be at a comma 0 and negative a comma 0, and from the center to one of your vertices is going to be a distance of a. So that's why I wrote down a equals 3, okay? So we know that later on when we come back. Now, B is going to have a purpose here, and I'll talk about that in a moment. But your foci are at c comma 0 and then negative c comma 0. And now your formula to get c is a bit different. Before, it was c squared equals a squared minus b squared. Okay, remember that. Now, c squared is going to be a squared plus b squared. Really easy to remember because it matches the letters and the exact format of the Pythagorean formula. Okay. Now, similarly, when we work with the hyperbola that's opening up and down, everything is just kind of swapped because we have something that's opening up and down. So now the vertices are going to be 0, a and 0, negative a. So they'll be on the y-axis in this case. And your foci will be on the y-axis as well now. So 0, c and 0, negative c. Notice that a and b have been swapped. Okay, so that's the most difficult thing with these formulas. They're swapping around letters, and that's where people get confused. And so as we move through this lesson, I'm going to show you not to use this formula. You can just come up with your own. Okay, so let's go back and let's talk about how we can get the rest of this stuff that's graphed here. So we know a equals 3. I can erase that here. I've already explained why. Basically, you want to think about, again, our equation is x squared over 9 plus y squared over 16 equals 1. And this is minus, not plus. Okay, so with this guy, I have these kind of 4 points that make up a rectangle. Where does that come from? Well, this is called the fundamental rectangle. So let me put fundamental rectangle like that. And basically what you do is you think about these as 4 points as the 4 corners or the 4 endpoints of the rectangle. And normally, depending on your equation, you're going to get something like a comma b, or you might get b comma a, depending again on the equation in your book. And then you go through the possibilities of that. Well, I'm going to tell you to not do that, okay? Let's not use those because they get confusing. Remember, this is an x coordinate and this is a y coordinate, okay? So for the x coordinate, go underneath x squared and look at your number here, okay? Take the square root, that's what you want, okay? Remember, go underneath x squared for x. That's all you got to remember. Go underneath y squared for y, take the square root of that number, it's 4. Then you're going to go through all the positive and negative combinations of that. So you've got 3 comma 4, you would have negative 3 comma 4. You would have 3 comma negative 4, and then you would have negative 3 comma negative 4. So those 4 guys there are going to give you your 4 endpoints. So your 3 comma 4, your 3 comma negative 4, your negative 3 comma 4, and your negative 3 comma negative 4. Okay, you can think about this guy, again, this is b squared. So the distance of b, you're going a distance of a units horizontally and a distance of b units vertically. So if I go 3 units to the right and 4 units up, if I go 3 units to the right and 4 units down, if I go 3 units to the left and 4 units up, and then 3 units left and 4 units down. So that's another way you can think about that. We know that c squared is equal to a squared plus b squared, okay? In this case, you don't have to remember what a is and what b is because you can just add these two. So 9 plus 16 is 25, so c squared would be 25. And just take the principal square root here, that would be 5. Okay, so c is 5. Remember, c is the distance from the center to the foci, so it's 5 units. 5 units to the right and 5 units to the left. And your foci are always going to be along the axis where you're opening, right? So if I'm opening along the x-axis, okay, I'm going to the right and to the left, well, my foci are going to be on that axis, okay? So it might be shifted if you get a different type of equation, but in this case, it's going to be on the x-axis because we're centered at the origin. So the foci would be 5 comma 0 and then negative 5 comma 0. Okay, so pretty easy to remember that as well. Now, the last thing I want to talk about is where we get these lines from. Basically, when you draw the fundamental rectangle, you can extend from the diagonals these lines, okay? These are your asymptotes. And basically, when you sketch the graph of these branches, as we say, right, each side is a different branch, you're going to sketch them to where they approach the asymptote, okay? They go through the vertex and then approach the asymptote, okay? So that's how you're going to do that. Now, another way to get these lines or these asymptotes, you have this, let me just erase this because my screen's going to get too busy. You have this formula that says y is equal to plus or minus, I'm just going to say rise over run, okay, and I'm going to tell you why in a minute, times x, okay? So why did I put rise over run? Well, because again, they use that b over a or a over b and it keeps switching and people get confused. So if you write rise over run here, you remember that rise is associated with the vertical movement or the y-axis, okay? How much am I going up and down? So y, I look at y squared, I look underneath, I get the square root of that number. So square root of 16 is 4. So you're going to put 4 there, okay? For the run, I think about x squared. Under x squared, I have 9. Square root of that is 3. Okay, so that's all you need to do. So these would be the two equations for these asymptotes, so you can get it that way as well. Basically, you would have y equals 4/3 x, start at the origin, go up 1, 2, 3, 4, to the right 1, 2, 3, there's a point. Then for the other one, y equals negative 4/3 x, start at the origin, go down 1, 2, 3, 4, to the right 1, 2, 3, there's a point, okay? So that's basically it when you talk about sketching the graph of a hyperbola. They generally want you to find the vertices, the foci, okay, the fundamental rectangle, the asymptotes, and then sketch the graph, okay? There's not much more to it. It can get shifted, like we're going to see in this example here, and then it gets a little bit more complex. So this one is going to be double complex because I gave it to you in general form, so you have to complete the square first. So you might get examples like this as well. And so let's blow through this real quick. We already know how to do this. We're going to group our x terms together. So negative 16x squared, and then I'm going to go plus my 32x and plus, well, let me not do that yet. So let me just kind of close this down. Then plus, we'll go 9y squared plus 18y. And then I'm going to add this 151 to each side so that it cancels over here and goes over here. So equals 151, okay? And basically, I'm doing this because I want to create a perfect square trinomial here, okay, here, and here, okay? So I'm going to add and subtract the same number inside of the parentheses. But before I can do that, remember the coefficient for your squared variable needs to be a 1. We're not going to divide anything here. We're going to factor. Okay, so I'm going to pull out a negative 16 here. I'm going to pull out a 9 here. So negative 16 times the quantity x squared. In this case, it would be minus 2x. Okay, and I'm going to leave a little space there. And then plus, I got to pull out a 9 here, times y squared. This would be plus 2y. We'll leave a little space there. And then this equals 151. Okay, so what goes here and here? Well, all you need to do is cut this coefficient here, the one on the variable raised to the first power, in half, meaning you multiply it by a half and then square it. If you have negative 2 times a half, you get negative 1. Negative 1 squared is 1. Same thing for 2. If you cut it in half, you get 1. 1 squared is 1. Okay, so in each case, you're going to end up with 1. So you add 1 and subtract 1. Add 1 and subtract 1, okay? But remember, you want only this part here because that's the perfect square trinomial. You want only this part here. But to do that and kind of get this part outside of the parentheses, you've got to distribute the negative 16 and you've got to distribute the 9. Okay, so that's very important. So what I'm going to do is say that I have negative 16 times the quantity. I'm going to close this down and factor it. So it's going to be x minus 1 quantity squared. And then it's going to be negative 16 times negative 1, which is plus 16. Okay, and then you're going to have plus your 9 times, I'm going to close this down and factor, so y, and it's going to be plus 1 quantity squared, and then 9 times negative 1 would be minus 9. This equals 151. Okay, so from here, it's kind of a piece of cake. Basically, what you want to do is say 16 minus 9 is going to give you 7. So let's just erase this and put a 7 here. And if I subtract 7 away from each side of the equation, this is going to cancel, okay? And then over here, this would become 144, okay? So I can say I have negative 16 times the quantity x minus 1 squared plus 9 times the quantity y plus 1 squared equals 144. Okay, so to finish this up, I want this to be a 1. So divide everything by 144, and you'll be done. Okay, so let's scroll down a little bit more. So in this case, 144 divided by 16 is 9. And you got the negative there. So let's make this a negative out in front and make this a 9 down here. And then 144 divided by 9 is 16. So let's make this a 16 down here. And we know this is a 1. Now, you typically don't want to write it like this. Whatever you have your minus out in front of, you want to put that in the middle. So you would want to say that this is the quantity y plus 1 squared over 16. And then minus, you have your quantity x minus 1 squared, and then over 9. And this equals 1. Okay, so let's go ahead and copy this. All right, let's go ahead and paste this in here. And we're just going to walk through how we get this. The way I like to do these is I like to think about my formula, okay, my generic formula without the a and the b involved. And then I shift them based on what the new center is, okay? So I pretend like the center is here, and then I shift it here, okay? So I'm going to shift all the points. So I just want to think about the fact that this guy is going to open up and down. We can see that clearly, but if we didn't know that, if we didn't have a graph in front of us, you have the minus here, and it's in front of where you have the x variable involved. So again, that's how we know that it's going to open up and down. Okay, if the minus was in front of where you had the y involved, you would open to the right and to the left. Now, let's talk about how you get the vertices. Okay, we know that with our other formula, if we had something like y squared over, let's say a squared, just for right now, then minus x squared over b squared, okay, and this equals 1. Well, this guy right here, again, I would take the square root of that, whatever that number is, okay, and I would say that my y-intercepts would be at 0, a, okay, and then 0, negative a. Okay, we talked about that already. That's how you find your vertices in this case. Well, here everything is shifted 1 unit down because of the plus 1, and 1 unit to the right because of the minus 1. So if I started with this guy right here and said, okay, my vertices would be at 0, 4 and 0, negative 4. Well, okay, I've got to shift it 1 unit down. So this would be a 3, okay, and this would be a negative 5. And then I would go 1 unit to the right, so this would be a 1 and this would be a 1. Okay, so I'm looking for 1, 3. So 1, 3, so that's right there. Let me choose a different color. So this is right there. And then 1, negative 5, so 1, negative 5 is going to be right there. Okay, so that's where those two vertices come from. Of course, the center comes from this right here, so it's minus whatever this is. Okay, so it's 1. This is not in that format, so you have to change it, right? If it's a plus 1, you think about it as minus a negative 1. Okay, so it's going to be at 1, negative 1. So 1, negative 1. So right there, that's your center. Now, let's talk a little bit about your foci. Okay, your foci. So we know that c squared is equal to a squared plus b squared. But again, everything is shifted, okay? So first you go again with the 16 plus 9, that's 25, okay? So you have c squared equals 25, so c is 5. So if this was centered at the origin, it would be at 0, 5 and 0, negative 5. But again, everything is shifted 1 unit to the right, so I'd put this at a 1 and a 1. And everything is shifted 1 unit down, so this would be a 4, and this would be a negative 6. So you'd have 1, 4, so 1, 4, so that's right there. And then 1, negative 6, so 1, negative 6, so that's right there. So that's where those two foci come from. Okay, let's talk about the fundamental rectangle now. Okay, so where do these endpoints come from? Again, I think about x, y. This is how I always write it. Okay, so where does x come from? Where does y come from? Okay, well, x comes from what's underneath the variable x. I know in this case it doesn't look like just x squared, but just go to where x is, go underneath, take the square root. So the square root of that is 3, okay? Then go underneath where y is, take the square root of that, that's 4. So you got 3, 4. Now, things have been shifted because the center's moved, okay? So you've got to account for that. So now what I'm going to say is that, let's just kind of go through the possibilities of this and we'll adjust. So it would be 3, 4, it would be negative 3, 4, it would be 3, negative 4, and then it would be negative 3, negative 4. Well, everything is shifted 1 unit to the right. So this one and this one would be 4. This one and this one would be negative 2. Okay. Then also, everything has shifted 1 unit down. So this one and this one would be 3. And this one and this one would be negative 5. Okay, so that's how I do it personally. You may have a different formula that works better, but that works for me. So you can see the endpoints of this guy are going to be 4, 3, so right there. And then you've got 4, negative 5, so right there. And then you've got negative 2, comma 3, so right there, and then negative 2, comma negative 5. Again, all you're really doing is saying from the center, okay, from the center, wherever that is, I'm going 3 units to the right and 4 units up. So from the center, if I go 3 units to the right, I go 1, 2, 3, and 4 units up, I go there. From the center, if I go 3 units to the left and 4 units up, I go there. From the center, if I go 3 units to the left and 4 units down, I go there. From the center, if I go 3 units to the right and 4 units down, I go there. So it's the same thought process. You just have to shift things because the center has moved. Now, you have your fundamental rectangle, so you can sketch the graph of the asymptotes. And at this point, if you're just told that you want to graph this guy, you're done. Okay, you don't need to go through and get the equation of these asymptotes. But if you do need that equation, okay, it is a little bit more work. Because now you're not going to be able to just say that y is equal to plus or minus, in this case, it would be 4/3 times x, because I took the 4 from here for the rise, the 3 from here for the run, okay? You can't just do that because the center's not at the origin, okay? So you have to take a point on this line, and you have to use point slope form, okay? You know the slope, right? It's still going to be 4/3 and then negative 4/3, but you don't exactly have the equation. So you have to go y minus y sub 1, and I'm going to take the y coordinate from the center, which is negative 1. So I'm going to say y minus y sub 1, y minus negative 1 is y plus 1, is equal to, I'm going to go with 4/3 first, times the quantity. You're going to have x minus, again from the center, the x coordinate is 1, so x minus 1. And so you would go through and figure this out. So you'd have y is equal to, subtract 1 away from each side, you'd have 4/3 x minus 4/3. And then I can go ahead and say this is minus 3/3. So this is 4/3 x minus 7/3. So that would be one equation. Okay. For the other one, you would need to work with negative 4/3. Okay. So y minus y sub 1, in this case, y sub 1 is negative 1, so y plus 1, equals negative 4/3 times the quantity x minus, in this case, our x value is 1. So we're going to say x minus 1. So what you'll have here is y is equal to, I'm going to subtract 1 away from each side. So negative 4/3 x, negative 4/3 times negative 1 is plus 4/3. Again, I subtracted 1 away from each side, so minus 3/3. So this would end up being 1/3 here. Okay, so this is 1/3. Okay, so I know this is long and tedious, but again, this is stuff that you do have to know. So let's kind of move this up here, and you can check this real quick. I know that the y-intercept of 1/3 is a little bit difficult to find, but let's just go ahead and say that that's right here, okay? And then the slope is negative 4/3. So if I go down 4, if I go down 1, 2, 3, 4, and I go to the right 3, so 1, 2, 3, you can see that should be about right there. Again, it's not perfect because we're not working with integers, but it's very, very close, okay? And then if you look at this one right here, 4/3 x minus 7/3, again, now I'm going with the positive slope. So if I look at negative 7/3, let's say that's about right there. So if I start here and go up 4, so 1, 2, 3, 4, and then go to the right 1, 2, 3, again, I'd be about right there. Okay, it's not perfect, but when you work with non-integer values, you're always going to be somewhat off. Okay, so that's where everything comes from in this particular case. If you're asked for your asymptotes, you know how to find them. If you're asked for your fundamental rectangle, you know how to get it. Basically, you just use the technique that we talked about. You just shift things based on where your center has moved. Okay, let's talk about one final topic. This is something that you will get, and it is a bit frustrating. So let's say you're given the vertices and the foci only, and they say come up with the equation. Okay, so it's a lot easier than you think. The vertices you're given, remember, from the center of the hyperbola to one of the vertices is the same distance from the center to the other vertex. So if I took these two and thought about the midpoint of this line segment, okay, that would be the center, okay, of this hyperbola. So I have -5 and -5. That doesn't change. So if the x value is not changing, okay, that tells me this guy is opening up and down, okay? So what I would do is say that the center is going to be -5 plus -5 is -10 divided by 2 and back to -5, right? That doesn't change. And then -1 plus -9 is -10 divided by 2, I get -5. So my center is at -5 comma -5. Okay, so what does that tell me? That I'm looking at something like this. I'm looking at something like y plus 5, right? Because it's always minus whatever it is. In this case, it's -5. Quantity squared over, let's just say a squared for now. Then minus, you would have x, again, plus 5, because it's -5. quantity squared. Let's say this is over b squared. This equals 1. So we need to find a squared and we need to find b squared. So what is a? A is the distance from the center to one of your vertices. Okay, well, if I went from -5, -5 to -5, -1, how far did I travel? Well, this, -5 and -5, that's the same, right? Because I'm traveling vertically. I'm going up. So all I need to compare is -5 to -1. How far did I travel? Well, 4 units, right? So that tells me a is 4, so a squared is 16. Okay, so I've got that part. Now I need b squared. Okay, and where this is going to come from is from that formula that a squared plus b squared equals c squared. Okay, and in this particular case, you've got your foci that occur at -5, -5 plus square root of 65, and -5, -5 minus the square root of 65. Okay, you only need one of these. But basically, c is the distance from the center, which again occurs at -5, -5, to one of these guys. Let's just say the -5, -5 plus square root of 65. Okay, well, we know this x-coordinate is the same in each case, so I'm just comparing the y-coordinates. So how far did I move in this case up, right? So I went, this is -5 and this is -5, so just erase those. You just have the square root of 65 left. So I'm traveling from the center up by the square root of 65 units. So that's going to be my c, okay? So c squared would be 65. So a squared is 16 and c squared is 65. Let me make that better. So what is b squared? Well, if I subtract 16 away from each side of this equation, I would see that b squared is equal to 49. And so that's all I need. I don't need to know that b is 7, right? I could take the square root, but I need b squared, so this is 49. So it seems a little bit harder than it is. It doesn't take that long, but you do have to kind of know what is a, that's the distance from the center to one of your vertices. What is c, that's the distance from your center to one of your foci. And then for getting b, you need to go through this formula and crank that out. So we get the quantity y plus 5 squared over 16 minus the quantity x plus 5 squared over 49 is equal to 1.